Hello my dear students, welcome back to the lecture series of continuity of function, and this is the last class of our chapter continuity of function, and this is lecture number 6. This is lecture number 7. So let me start with a problem. Find the value of lambda for which the function f(x) is equal to, this is our function, is continuous at x is equal to 0. And the second question is, what about the continuity at x is equal to 1? So there are actually two questions. The first one, to obtain the value of lambda, and the second one, to find to say what about the continuity of the function at x is equal to 1. So let me begin with the first question. Here, to find the value of lambda, and it is given that the function, this one, is continuous at x is equal to 0, and you see the point 0, this is a point of separation, because less than 0 fx is this one, and for greater than 0 fx is this one. So different definitions for function, and therefore we start with the line that the function continuous, therefore left limit equal to the right limit at the point x is equal to 0. So you see here, since the function is continuous at x is equal to 0, therefore limit x tends to 0 minus fx equals limit x tends to 0 plus fx. 0 minus, alternative meaning is x less than 0, and so fx is here lambda into x square minus 2x. So, and for x greater than 0, fx is equal to 4x plus 1, and we should replace here. So you see that line, limit is there, fx is this line, and this fx is replaced by 4x plus 1, you see here. Then just converting the limit in terms of h, and that is very simple. H tends to 0, lambda is here, x is replaced by 0 minus h, so 0 minus h, 2 into here, and h is again replaced by 0 minus h, and on the right hand side you see x is replaced by 0 plus h, and so here 0 plus h, this is a 0 plus, and this new variable h, this one plus 1 is already there. Now using the limit, it is very simple. Lambda is remaining same, h is 0, you see this is 0 and this is also 0, so total entire term here, total term is equal to 0. So lambda into 0 is equal to, on the right side, this h0, so will be 1 only, on the right hand side will be 1 only. So 0 equal to 1, and this is an absurd case, impossible case. And you see, if you take lambda is equal to, say I am taking lambda equal to say 1, if you take lambda is equal to 1, in that case the final line will be 1 into 0 is equal to 1, and that is again equal to 0 equal to minus 1. Similarly, if you take lambda is equal to say 2, if you take lambda is equal to 2, then final line will be 2 into 0 is equal to 0 equal to 1, and then 0 is equal to 1. So whatever be the value you are taking for lambda, then in all cases you will get 0 is equal to 1, and which is not possible in any case. That means there is no such value of lambda for which this line is correct. So that is why we are writing here which is impossible for any value of lambda. So if you take lambda equal to 1, lambda equal to 2, lambda equal to 3, lambda equal to half, negative values, negative rational values, any value, in all cases we will get this absurd line. And that is why there is no value of lambda for which this function can be continuous, because 0 is never is equal to 1, mean in all cases we will get for this function the left hand limit and the right hand limit will be different, mean lambda is for any value of lambda, the left hand limit is always be is equal to 0, and right hand limit is always be equal to 1. So whatever be the value of lambda you are taking, in all cases we will get the function is a discontinuous function, mean there is no chance to make the function as a continuous function. So there is no such value of lambda for which the function is continuous at x is equal to 0. So that is the answer of the first question. And now you come to the second question, what about the continuity at x is equal to 1? So x is equal to 1 is in this branch of the function, because 1 is greater than 0. Therefore, for x greater than 0, fx is equal to 4x plus 1, and we are taking fx for x equal to 1, and equal to 1 is for here. So fx will be equal to 4x plus 1. So we write that line. So again, when x is equal to 1, then fx is equal to 4x plus 1. This one, 4x plus 1. And 4x plus 1 is a polynomial function. And we know that any polynomial function is continuous everywhere. So it is continuous everywhere mean continuous in R. Therefore, it is continuous in at the point 1 also. So you write that which is a polynomial. Therefore, the function is continuous for all x belongs to R. So it is also continuous at the point x is equal to 1. So that is the solution for the question. So we take the fresh question. This is our question. Discuss the continuity of the function. Function is here. Fx is equal to sin x plus cos x. Then the second question is gx is equal to sin x minus cos x. Then the third question is hx is equal to sin x into cos x. All these three questions are included in your NCERT main book, and so I am going to solve one of these three questions because all the three questions are similar type. So I am taking the question number A, say. So you take that question A. The question is fx is equal to sin x plus cos x. So here no point is indicating to check the continuity. Just you are to check for whole region, for whole values of x. So therefore we take any arbitrary value of x in the domain of the function. Domain must be R because sin x function domain is R and cos x function domain is also R. Therefore sum of these two functions has the domain again R. Therefore we take, let x is equal to a be any arbitrary point in the domain R of the function. Then for that point x is equal to 1, you take the left hand limit, you take the right hand limit, and you also take the function value. And if all these three values are equal, then we can say that the function is continuous. So we write this: left hand limit is equal to limit x tends to a minus fx. Limit x tends to a minus fx is the same function sin x plus cos x. So we write sin x plus cos x. So limit h tends to 0 by making this h. Then x replaced by a minus h, so it is a minus h. Then here it is a minus h. Then you see here using the limit h is 0, so simply it is sin a plus cos a, sin a plus cos a. Then in the similar manner you take the right hand limit. This time it is a plus h. This is a plus, function is same, function is sin x plus cos x, making h tends to 0. So x is a plus h, then using limit it will be equal to sin a plus cos a. So left hand limit sin a plus cos a, right hand limit sin a plus cos a, they are equal. So we are taking the value of the function at x is equal to a, mean the functional value. So fa will be equal to direct replacement of x, it is sin a plus cos a. And so you see the left hand limit, the right hand limit, and the function value all are equal. So we are writing left hand limit, right hand limit equal to fa. So the function is continuous at x is equal to a, but x is equal to a, this was arbitrary point. Here you see it is arbitrary point of the domain R, and R mean any value. So the function, hence the function is continuous at all points of its domain. Okay, so in the similar way you can take the second question, just here minus, you replace here minus, here will be minus, here is minus. So for product you just give here product sign, this will be product, this will be product, this will be product, this is product. So the rest of the two questions B and C are of the same type, so you can solve the two problems yourself. So I am going to the next question, number 25. You say, prove that fx is equal to modulus of cos x is a continuous function. This is one important question actually, and this function is mod of cos x are the composition of two functions actually. There are two functions. So one of the function is cos x and other function is mod. So for this question you are to use the theory of composition of function. I am discussing that one here. Actually this is a major part in the chapter function we will discuss later on. And so for this question you can you can understand the function mod of cos x very easily. You see here. So here two functions, I already told you there are two functions. One of the function is mod function, so we are taking mod x, and the other function is inside mod, it is cos x, so taking gx is equal to cos x. So hx is mod x, gx is cos x. Now if you compose these two functions hx and gx, then we will get the function fx. You see here, this is HOZ of x. HOZ, this is the process of writing two composite function. HOZ, that is H is operating on G. So H, this if you do not write this O here of composition O, then it should be written like H of Gx. It will be discussed in the chapter function in details. You may also go through my channel. There is a video for composition of function, and you can see that video. So if you see that video, you will get the composition of function, how to take composition of function. That will be clear for you. And so here, if you do not write this O here, then it will be H of Gx. Then H is remaining here, but what is Gx here? Gx is cos x, so writing here cos x. Now go to the function H. So H of x is equal to mod of x, mean this is x, inside mod it is also x. So this time H of cos x, therefore inside mod it will be cos x. And you see, this is mod cos x is nothing but the given function fx. So HOZ of x is equal to fx. And we have a theorem in this chapter beginning, at the very beginning we discussed a theorem that if H is continuous, Z is continuous, then HOZ is also continuous. So we should use that theorem to prove this function mod of cos x is a continuous function. So now separately you prove that sin hx is equal to mod x is a continuous function, and gx is equal to cos x is also a continuous function. You should separately prove these two are continuous functions. And after that, by using that theorem, if h is continuous, z is continuous, then HOZ is also continuous. So we should use that theorem. And here, before beginning of the continuity part, you have to show that this given function is the composition of h and g, as like this. In each and every problem, HOZ should be obtained like this. So first of all, you check hx is equal to mod x is a continuous function, and it is very simple. We have done earlier that mod x is a continuous function. So we write the continuity part of hx as hx is equal to mod x, removing the modulus sign. By definition of mod x, it is simply this one. Then here the possible point of discontinuity is 0, and the other point it is continuous, because for greater than 0 it is polynomial, for less than 0 it is also polynomial. So we write that. Here the possible point of discontinuity is x is equal to 0. At all other points the function is obviously continuous, because the function is polynomial at those points. Now at x is equal to 0, you just find left hand limit and right hand limit and function value. So left hand limit, x tends to 0 minus hx, 0 minus mean less than 0, it is minus x, and so minus x should be replaced by 0 minus h like this, and h is 0, so left hand limit is 0. Then right hand limit, 0 plus hx, function is x, this one, then 0 plus h, and using 0 only 0. And so f0, so f0, not f0, it is h0, function is h, so h0 is equal to 0, because equal 0 is in the first line. So h0 is equal to mod 0, and that is also is equal to 0. So thus left hand limit, right hand limit and f0 all are equal, hence the function is continuous at x is equal to 0. That is doubtful point. At the doubtful point the function is also continuous. Thus it is a continuous function in R, because less than, greater than, less than 0, greater than 0 and 0, if you combine all this point, then you will get the real line. So it is continuous for all real values of x. That means the function hx is equal to mod x is a continuous function. Then for the second one, gx is equal to cos x, it is already done, we take that one. So for gx is equal to cos x, this time point is not there, therefore we take let x is equal to a, b, any arbitrary point in the domain R of gx. Then left hand limit is this one, already discussed, so I think you understood this line. Similarly, right hand limit is also cos a. Similarly, function value ga is also is equal to cos a. Therefore, left hand limit, right hand limit and ga are equal. So the function is continuous at x is equal to a. But x is equal to a is an arbitrary point of domain R. So the function is also continuous in R. So now you see the first function hx, that is continuous in R, and the function gx is also continuous in R. Therefore, by that theorem, goh is also continuous in the domain R. So we write that line. Therefore, the function fx is equal to HOG of x is equal to mod of cos x is also continuous function. Okay, so that completes the solution of the question. So I think you understood this question, and this question will be better understandable if you see that video, the composition of function, that is included in my channel. You may see that video. Okay, so come to the next question. Prove that the function fx is equal to cos x square is a continuous function. Similar question you see here, I am writing here, I am giving some hints for you. You see there are actually, you take two functions, say gx is equal to, there are two functions, one of the function is cos, you should take x here, and the second function is say hx, that function is x square, because primary function is actually cos function, primary function not x square, it is cos x. Therefore, you should write like this. These are the two functions. Then you find goh of x, and that is equal to zhx. O is removing, you should write hx here, z of hx. Then hx is equal to x square, you write that z of x square. Then go to the definition of z function, you see here z function cos x, gx is equal to cos x, so gx square will be cos x square, so you write that one cos x square, it will be cos x square, and that is actually is equal to fx. This is cos x square, and so that is equal to fx. Now you should prove this function is continuous, fx is continuous, and for that you prove gx is continuous and hx is continuous. Okay, so I am erasing this. Very simple question. You just write these lines. You see here. So so these two functions, one of the function is cos x and other function is x square. X square is polynomial, so it is obviously continuous, and cos x is continuous should be proved as like in the previous question. Cos x is a continuous function, and that can be proved by the help of the previous question. And x square, you can directly write that it is a polynomial function, so it is continuous in R, and the rest of the section you can write yourself. So this question is homework for you. Then we take the next question. Prove that fx equal to sine of mod x is a continuous function. Again, this is composition. The first function is sine. In the primary definition of sine function, it is not sine mod x, it is sine x. So one of the function is sine x, and the second function is mod x. So we write that two functions, hx and gx. So let gx is equal to, I am taking sine x, and hx is equal to, I am taking mod x. Now you see this fx is actually composition of gx and hx. Okay, so goh of x equal to z of hx, then g of hx is mod x. Then go to the definition of z. If z of x, then it is sine of x, but this time z of mod x, so you should write sine of x is mod x, and sine mod x, this is actually fx, you see here. It is actually fx. So now you are to prove separately that this gx function and this hx function are continuous function. Gx equal to sin x, it is very simple. You should just prove sin x is a continuous function by taking arbitrary point, and that is very simple. You write like this: gx equal to sin x and hx is equal to mod x are continuous function. But you are to prove these two. You are to prove these two parts separately. Hx is equal to mod x, you can take help from the previous question, and gx is equal to sin x is continuous, and you can also take help from the previous questions. So I am leaving that part for you. So you see here you should include the prove part. Prove it এইখিনি prove কৰিব লাগিব, prove it by the help of the previous question. Okay, so therefore fx equal to goh is a continuous function. This will be the last line. Gx is continuous by taking arbitrary point and modulus function. First remove the modulus sign, then prove it is a continuous function. So you solve the rest of the section and show me. Okay, and if you have any problem then you can ask. Okay, then you see this question: show that the function defined by fx is equal to this one, where x is a real number, is a continuous function. And this is a problem of your NCERT book, and actually this problem is an example in your main book, NCERT main book. This is already solved in your book, but I am going to solve this question for you for better understanding. Okay, so let these two functions, actually again there are two functions. This outer modulus function, actually fx is equal to this total mod of this is x total, considering this total part as x. So z function is mod x and h function is this considering part, this one. So these are the two functions. So gx is continuous. You can solve like this. goh, first of all you should show that goh is equal to fx. So goh of x, g of o is removing, so hx, but hx is this part, we are writing this part, then is equal to h, you see z function definition, z of x, then it is mod of x. So z of this part, so mod of this part, this one, and this total entire part is nothing but fx. This is fx. Now you should prove this z function and this h function both are continuous function. So here the function gx is equal to mod x is a continuous function in R. You have to prove this. But if 2 marks is given for this question, then it is not necessary to prove. You can directly write gx is equal to mod x is a continuous function as like this. But if mark is 4 or more mark, then you are to prove that part by using the previous process. How to check the continuity of modulus function, you already know that. And then fx is equal to this hx function, this is the hx function, and it is the sum of a constant function. This is constant, this is polynomial, this is also polynomial actually. So continuous polynomial function, continuous, this is continuous. So sum and difference of continuous functions are also continuous. You already know, we have theorem, algebra of continuity. In that part we already have written that sum of continuous function is continuous, difference of continuous function is continuous, product of continuous function is continuous. So here it is the sum of polynomial function and constant function, so it is obviously continuous function because polynomial is continuous function. Constant function is also constant function is also continuous functions. So therefore you write here again hx is equal to this is a sum of polynomial functions which are continuous in R. Therefore hx is equal to this total function is also continuous in R. Hence the composition fx is equal to goh of x. This is fx is equal to, you see here, this fx is equal to goh of x is equal to this part is a continuous function. So this completes the solution of the problem. Okay, so the next question, determine the values of a, b and c for which the function fx is equal to this is continuous at x is equal to 0. And it is one entrance based question, interesting question. So you are to determine the values of this a, this b and this c, but it is given that this function is a continuous function. So continuous function mean its left hand limit, continuous function at 0, you see here at 0. So left hand limit is in this line, right hand limit is in this line, and functional value is in this line. So you are to use all these three definitions. So you write, since the function is continuous at x is equal to 0, therefore left hand limit is equal to right hand limit is equal to f0. f0 means functional value. So left hand limit is from this line, right hand limit is from this line, and function value is from this line. We write that line. So limit x tends to 0 minus fx, x tends to 0 plus fx, and f0. So it is limit x tends to 0 minus less than 0. So you are to take fx equal to this. X tends to 0 plus mean greater than 0. So you are to take fx is equal to this, and f0 mean equal 0, this line. So you are to take c, this one, mark it by 1. Then go to the next screen. H tends to 0. Sorry, the last line is written here. You see, left hand side is similar. Okay, this is to get the formula actually, because we have a formula sin x by x is equal to 1. You know that this formula already we know. Limit x tends to some 0, it is sin x over x, this value is equal to 1. So to get this formula, I am taking this line here, and you see here a plus 1 is the extra term. So you are to multiply by a plus 1 here also, and the second part is simply sin x by x. Okay, so I am erasing this. Okay, then you see, just you see here, so this part is from this part actually, this part is written here, and sin x by x is already here, sin x by x. Okay, so then using the limit only, this is 1, a plus 1 is remaining same, and this value is obviously 1. You can make this limit to h, so the final value will be, it is a plus 1 is equal to 2. So a plus 2 is the left hand limit. This is left hand limit. Then obtain the right hand limit also. So 0 plus, this was the function, 0 plus, I am actually writing here this one. You see root over this one, root over x plus bx square. Very simple actually, just try to understand. X plus bx square. So if you take x common inside the radical sign, x is common, so it is obviously 1 plus, sorry, it is not x, it is 1 plus bx, then it can be written like this, root x into root over 1 plus bx. This is actually this one. So after writing here, you can take root x is common. So root x is common. From this one, 1 plus bx root over will remain, and from this one, 1 will be remain. And the denominator b x to the power 3 by 2 is nothing but x root x, you see. Then this root x can be cancelled out. So limit h tends to 0. Here this part is remaining, and denominator bx is remaining. Okay, so now using before to find this limit, you know the method. You are to rationalize this numerator. By multiplying by the conjugate. You know that method from your first year. first year class. Already we discussed in the chapter limit of function. So to find the types of limit, you have to multiply by the conjugate. Okay, so after taking conjugate multiplication, this is a square minus b square, so 1 plus b root over 1 plus b whole square will be equal to simply 1 plus bx, and minus 1 square is 1, bx is already there, and this conjugate part is root over. Denominator should be also multiplied by the conjugate, it is root over 1 plus bx then plus 1. So x tends to 0, 1 and 1 is cancelled, this bx and bx is cancelled, so it is 1 by this 1 plus bx root over and then plus 1. Using the limit, you see it is simply 1 by 2 because this part is 0, so 1 plus 1 will give us 2 only. So this is our left limit a plus 2, this is our right limit half, and f0 that is already c, it is in the equation number 1. So we start with the equation number 1. This is 1 implies left limit is a plus 2, right limit is half, and function value is already c. Then you see from here c is equal to half, from here c is equal to half. So you see a is equal to half minus 2, this is minus 3 by 2, and c is simply equal to half. Okay, so from this you cannot obtain the value of b. You see b is already removed, actually b is removed here, cancelled, numerator denominator cancelled, because 1 and 1 will go, bx is always cancelled. Now you see what are the possible values of b here. You see, if you take b is equal to 1, then also it will be x by x will be cancelled. If you take b equal to say 2, then it will be 2x by 2x will be cancelled out. Say b equal to minus 3, it is minus 3x upon minus 3x will again cancel, mean b can take any value. B can take any values, because in all cases this 2 will be cancelled and this part will be 0 here. In all cases you will get the limit is equal to half. So actually b can take all values, mean r, but if you think deeply, that b cannot take 0, because in that case this denominator will be equal to 0, mean the entire function will be undefined. So b can take all values but not the value 0. So therefore the value of b is real, mean r minus the point 0. Okay, so you simply write that line clearly. From the evaluation of the right hand limit, mean this one, this is the evaluation of right hand limit. We see that b, it may be any value, therefore it is r, but not the point 0. Why it is not 0? Because if b 0, then the function will be undefined, infinite. So b is equal to r minus 0, a is equal to minus 3 by 2, and c is equal to 1 by 2. And that is the completion of the question. And we finish this video. And in the next class, we will discuss some more questions about, in the next video, we will discuss about differentiability, because this was the last video of continuity of functions. And in the next day, in the next class, we will begin the chapter differentiability, and we will take only 2 videos for that part. Okay, so till then, thank you very much.